Hello, everyone. I hope you're doing as well as can be under the circumstances. This video is going to go into the solution for the traffic light problem. Before I get into it, I just want to point out really quickly that the three different tensions are all acting on this point right here. This knot, so that's going to be the origin for the forces. So we need to draw a force diagram to solve this problem. We'll start with that knot as the origin of the forces. We have the weight of the traffic light straight down. We have a force going up to the right and a force going up to the left. We need to identify the X and Y components for each of those forces. Now they form right triangles, and I'm just drawing the triangles separate so that we can kind of focus in on them and see how the trig functions play out against the angles that are there. Now, the traffic light was given to us as 100 newtons, so that was already a force. So that means that the tension down here, which would be T2, is 100 newtons. Just keep that in mind when you see these problems. If you're given a quantity in newtons, it's already a force. If it was given to you in kilograms, then you would multiply by gravity in order to get it as a force. All right, I'm just going to move these to the left so that we can start writing some equations. The first equation is going to be the sum of the forces in the x direction equals ma. This is just applying Newton's second law. Now, this is a case of static equilibrium, so the net force is zero because there is no acceleration. Acceleration is zero. The forces that we have in the x direction, we have a T3x and a T1x. Now, T3x is to the right, so it's positive. T1x is to the left, so it's negative. Okay? So T3x minus T1x equals 0. Therefore, T3x equals T1x, equal and opposite. Let's write them in terms of the trig function. In this case, it's the adjacent side to the angle, so it'll be cosine. Let's repeat the same thing for the y direction. Again, there is no acceleration in the y direction, so all those forces will add up to 0. We have three forces in the y direction. We have T3y going up and T1y going up, so those are both positive. And then we have 100 newtons going down, so that will be negative. Write these in terms of the sine of the angles. And we have T1 sine 37 plus T3 sine 53 equals 100 newtons. I just added 100 to both sides to get it over here. Okay, so here are our two sum of the force equations. We have the x direction and the y direction. The problem that we see now is we have two unknowns, T3 and T1. So this causes a problem. How do we solve problems like this? So there's a technique called solving simultaneous equations. And that's what we're going to apply to this situation in order to solve it. So anytime you're faced with a situation where you have two unknowns, you have to apply this technique of solving simultaneous equations. So let me show you what that means. So we have this x equation with the two unknowns, and what we're going to do is we're going to solve in terms of one of the unknowns. All right, so I chose to solve for T3. Okay, now I still don't know what the answer is. I can't figure out what T3 is because I don't know what T1 is. Right? Cosine of 37 is a number. Cosine of 53 is a number. But again, that would just give me T3 is equal to T1 times some number. All right, let's go back to the y equation. All right, we see T1 and T3. What we're going to do now is we're going to take what we solved from the x equation in terms of T3, and we're going to substitute it into the y equation. Okay, this is the simultaneous part. Okay, so everywhere that we see T3 in the y equation, we're going to write all this stuff in there. Okay, and when we do that, it's going to give us only one unknown. It's going to give us the one unknown of T1. All right, so this is what it looks like when you just fill it all in and write it out. Now, this other simplification that I'm making here is just when we have sine of an angle divided by cosine of the same angle, we can write that as tangent of the angle. So that's all I did right there. All right, so we've reduced this the problem now to just one unknown. Okay, we have T1 here and here. So I'm just going to do some algebra to simplify it. I've taken the T1 out, brackets. I've got T1 in just one location. And all this stuff in here is just a number, right? Sine of 37, you can put that in your calculator. It'll give you a number plus cosine of 37 times tangent of 53. Again, just all a number. So when you do all that out in your calculator, you're going to get T1 times 1.66 equals 100 newtons. Divide both sides by 1.66, and T1 comes out to 60.2 newtons. Okay, now that we know what T1 is, we can go back to that other equation where we solve for T3, and we can plug in this new value for T1, and now we can solve for T3. All right, so T3 is equal to 60.2 newtons times the cosine of 37 divided by the cosine of 53. We do that out and we get 79.9. So now we have all the answers to the tensions. Okay, so there's your solution to the traffic light problem.